This is part 2 for the review for the polynomial radicals and graphs test. This is the review sheet, so let's start with number 11. Solve for x. Well, you can't have adding or subtracting with the square root, or at least you want to move that over. So we're going to add 10 to both sides as our first step and get the square root of 5x plus 5 equals 10. And then we will square both sides and get 5x plus 5 equals 100. Subtract 5 from both sides and get 5x equals 95. And then divide both sides by 5 and you get x equals 19. Keep in mind you can always double check this. You can just plug 19 back in for x and then see if that equals out like it should. Okay, number 12, solve for x. Now notice, we're not adding or subtracting here, we're multiplying. So it's okay to leave that 2 there, that's not a problem. We can square both sides. X squared is x squared. And then we have to square both things inside. We have to do 2 squared, which is 4, and square root of x squared, which is x. Anytime you have two different powers of x, we have an x squared on one side and an x to the first on the other, the best thing to do is get it set equal to 0 and try to factor it. I get x squared minus 4x equals 0, and then pull x out of both sides, or excuse me, both pieces, leaving me with this. Now I can set each piece individually equal to 0. X equals 0 is one answer. Then add 4 to the other one and you get x equals 4. Go back and double check, make sure that works. You plug 0 in both sides, that's no problem. Plug 4 in both sides, no problem. 13. Solve for x. We need to get rid of that 3/2 exponent. The way we do that is by raising both sides to the opposite or the reciprocal, which would be 2/3. So the 2/3 cancels out the 3/2, leaving just x minus 4. And you can plug 27 to the 2/3 in your calculator and you should get 9. So now we just add 4 to both sides and we get our final answer, which is 13. Number 14. This may be small, but you have your review sheet, so just follow along with me there. It says use your calculator to run a power regression of the data. Write the equation your calculator gives you below. Okay, I already have this plugged in our calculator up on the smartboard here. So if you go to Stat, Edit, you want to make sure you plug them all in there. And then make sure your stat plot is on. So go to y equals, just make sure you go to plot 1, hit enter, make sure it's on. Then go to Stat, Calc, and you want to go all the way down to where it says Power Regression. Okay, sorry, I went a little too far. There we go. It's A, Power Regression, hit enter. And I am going to go ahead and plug it in y1. Don't forget, if you go right here, you can use vars, yvars, function, y1, and that will automatically plug it into y equals 4u, so you can graph it. Okay, so you see what we get here. It's a times x raised to the b. So 5.057 x raised to the 0.328. Remember, we're going to, I have nearest tenth on here. Well, on your test it'll be the nearest thousandth. So we're going to go with the 3 decimal places. I just hadn't replaced that yet on your review sheet, but it'll be that way in your test. Okay, so B, using the equation from part A, estimate the pay per hour for someone who's worked for 8 years. Okay, if you look over here, X always comes first. So X is the years worked, Y is the pay per hour. And this would be a Y equals function. So pay per hour for someone who's worked 8 years. So years worked is your X value, so I can plug in 5.057 times 8 raised to the 0.328. So I can plug this in, see what I get. Actually, well, yeah, 5.057 times 8 raised to the 0.328. And we get about $10 an hour. Okay, now part C is a little tougher to at least solve by hand. So it says using the equation for what I estimate the years worked for someone who is paid $16 an hour? Well, pay per hour is the y value, so we would plug 16 in for y. There is a way to solve this by hand, but it's pretty difficult. Not something we've done yet in this course anyway. So I would recommend, instead of trying to solve that by hand, doing guess and check in your calculator. You've already plugged in y equals, and if you haven't, you can do it now, and then go to your table. Go second, table, and then you can just kind of guess and check. Okay, well, let's try to be smart about our guesses here. If you look at our chart, if they worked for 15 years, they get paid $12 an hour. So we're trying to figure out getting paid $16 an hour. So we definitely need more than 15 years worked. So I'm going to guess they need 25 years worked. Okay, so they're up to $14.54 an hour. That's still not quite enough. Let's try 30. Okay, that's still not quite to 16. Let's try 35. Okay, that's a little over 16. So let's back up a couple steps and look at 33 and 34. Okay, so both of those are pretty close to 16. To actually pass $16 an hour, they would need to have worked 34 years. So 34 years worked would get them the $16 an hour. And that's probably the simplest way to do that, is to use your calculator and use the table to guess and check. And that's what I'd recommend. Using the table to the right, this is the last question, answer the following. First, find r squared for the linear, quadratic, cubic, and quartic regressions and write them below. We're just looking for the r squared. You don't have to write the whole equations. So make sure you go to Stat, Edit, and you plug in all these points. Don't forget to do that first. And then we go to Stat, Calc, and first we'll do linear regression. Okay, and I get an r squared value of 0.88. We'll just say 0.882. So for linear, my r squared was 0.882. Not terrible, but not that good either. So it would seem that that's not a good fit. Let's try quadratic. Stat, Calc, quadratic. We get an, r squared of 0.938. Okay, that's getting better. Quadratic is 0.938. This is my r squared again. This helps you figure out the goodness of fit. In other words, is a quadratic or linear or cubic or quartic the best model for this? Okay, now let's go to Stat, Calc, and do cubic, which is number 6. And this one we get an r squared of 0.995. That is looking pretty good. 0.995. Okay, so cubic, 0.995. But let's go ahead and try quartic. Stat, Calc, quartic is 7. And this r squared, have to move down 1, is 0.995 also. If they're both that similar, I would absolutely accept either one. So cubic or quartic. You can give me either one. So which model do you think is best as y? Well, you could pick either one. For this particular problem, I'd accept either one. If you want, you can go to your stat plot. Make sure it's on. Need to delete that other one. And then go to the graph. And you'll actually need to go to Zoom Stat, which is Zoom 9, and see it. I would probably personally lean toward cubic here, but you can do either one. To me, just the way it curves a little reminds me a little more of a cubic than a quartic, but both would be acceptable. You just need to explain why, and you can say because it fits the data best, because the r squared is the closest to 1. Because that's what you're going for. The closer r squared is to 1, the better it is. And then write the equation of the model you think is best below. So I'll just go back and pull up the cubic one again. Stat, Calc, cubic is 6. And I'm going to get negative 2.432x cubed plus 37.317x squared minus 70.372x and 1043.788. Good luck, guys.